All right, let's take a look at this example. The velocity function in meters per second is given for a particle moving along a line by this formula, 3t minus 5 on this interval from 0 to 3. We want to find the displacement and finding total distance traveled by this particle during this time interval. So we know that displacement is change in position. It measures the difference in where we start and where we end, whereas the total distance traveled will be adding up everything. So pretty much if you were to come up with a picture to help you understand this scenario, for this function, well, because the velocity function is this, so it looks like when t equals 0, the function starts at -5. So maybe we'll be traveling left and then maybe traveling to the right. So something like that. So displacement will be from here to here. So this distance that we're going to compute, this is going to be the displacement. Whereas the total distance traveled will be adding up this distance and this distance. That will be the total distance traveled. So let's see, how do we calculate that? So a displacement, we know that it's going to be the integral from some, let's call it A, we'll call it t sub 1 to t sub 2 of the velocity function dt. So that's for part A, displacement. That is the definition of how to find the displacement. So I'm going to substitute my v of t. T1, it's going to be 0. T2, it's 3. Our velocity function is 3t minus 5. We integrate respect to t. Then you proceed with the integral. You find the antiderivative of this function and that. So you're going to get 3 over 2t squared minus 5t. And then you evaluate this from 0 to 3. Then we plug in the upper limit into the value of t. So you have 3 over 2, 3 squared, minus 5 times 3. The lower limit, when you plug in 0 for each of these t, you're going to get 0. So let's just say minus 0. And then if you evaluate this, this will give you 3 over 2 times 9 minus 15, which will come out to be negative 3 over 2 meters. So that will be our answer to the first part of this problem. This should be negative 3 over 2. All right, so that is for part A. Now for part B, we're going to find the distance traveled. So we do need to consider when we're moving left. So we can throw in the absolute value because we want to count that in as distance traveled, although it traveled to the left. So to add up everything, we do need to do the following first. So for part B, this is for the total distance traveled within that interval of 0 to 3. So let's see, where is the velocity function negative within this interval? So here's our interval from 0 to 3. We're going to be looking at the velocity function. See, where is it negative? So first, let's find out where is it equal to 0. So I want to see when this is equal to 0. So I simply take my function v of t, set it equal to 0. Then t would give you 5 over 3. So 5 over 3 is about 1.6. So let's say it's right here. So that's when it is at rest. So that means now we can figure out if the velocity is positive, negative in this interval from 0 to 5 over 3, and if the velocity is positive or negative in this interval. So you can do this by graphing the velocity function. So since it's a linear function, you can actually draw it. So if you don't do the interval test, you can also look at it like this. So the velocity function, we know it was given to be 3t minus 5. So when t is 0, it's going to be at -5. And then when t is 3, you're going to have 9 minus 5. So it's a positive value up here. So we know it's going to look something like this. So that means that at some point right here, it hits a rest, which is 5 over 3. So we know we're going to be negative area in this portion, positive area in this portion. So we know we're interpreting as distance, so not area. So we're going to consider traveling to the left for this portion of the region and traveling to the right for this portion of the interval. All right, so let's go ahead and pick a test value and plug it in. So again, this part, you don't have to do this. You can just pick a test value within each interval, plug it into v of t and see if it's positive or negative. So I'm going to go ahead and do that since that seems to be more convenient. So let's figure out what is a test value, good test value within this interval 0 to 5 over 3, we can test t equals 1. And then in this interval, we can test t equals 2. Anything within the interval, I'm going for something convenient. So let's see what is v at 1. So if you plug in 1, it will be 3 times 1 minus 5. That will certainly be negative value, so it's negative. And then you'll plug in 2 into v, you'll have 3 times 2 minus 5. That will be positive. So here it's positive, here it's negative. So we know when to throw in the absolute value. Okay, so now we can calculate our total distance. So our distance traveled, it's going to be the integral from 0 to 3 of the absolute value of v of t dt. And this is where we split this up. So from 0 to 5 over 3, we keep the absolute value around v. Then from 5 over 3 to 3, it's positive, so we don't need the absolute value. Your integral can just simply go from 5 over 3 to 3 of the original v of t. Now, how do we take care of this part? Well, let's think about it. So I'm going to go ahead and write it like this. So the integral from 0 to 5 over 3, we're going to have negative v of t because we know our distance in that interval is negative. So we need that extra negative to cancel that negative out. And the last one, we just do it as it is. So this is 5 over 3 to 3 of v of t, which is 3t minus 5 dt. So now here I'm going to throw in the 3t minus 5, but don't forget to distribute the negative. So this is 3t minus 5. Now if you distribute the negative out, you'll have the integral from 0 to 5 over 3, negative 3t plus 5. So you could do it this way, or once you have your answer after the integration is done, you can throw in the absolute value. You could also do it that way. That's totally fine. I prefer to do it this way, so I just add everything up at the end. So let's continue on this way. So plus this integral, which we already know how to do, I'm just going to rewrite one more time and take care of everything at once. All right, so that is my setup. So let's integrate. So we know the integral of 3t, that is going to be 3 over 2t squared plus 5t. This will be evaluated from 0 to 5 over 3. The second one, again, same antiderivative. This is 3t squared over 2 minus 5t, evaluated from 5 over 3 to 3. Okay, now let's go ahead and plug in the upper limit and lower limit carefully. So we'll first plug in 5 over 3 into each t. So you have negative 3 over 2 times 5 over 3 squared plus 5 over 3 times 5, and then minus, when you plug in the lower limit 0 into each t, it disappears. So we know this is 0. All right, now the second part. We're going to plug in first 3 into each t. So you'll have 3 over 2 times 3 squared minus 5 times 3 minus now the lower limit. So here, be careful. You're plugging in a lower limit for each t. Don't forget the parentheses. This is 3 over 2 times 5 over 3 squared minus 5 times 5 over 3. Okay, now let's clear this up a little bit more. So we have 3 over 2 times, so for this part, we're going to get 25 over 9. For the second one, 25 over 3. For the next term, we have plus 3 over 2 times 9. That's 27 over 3, sorry, 2. And then we're going to get minus 15. Then the next time here, I distribute the negative out as well. So I'll have negative 3 over 2 times 25 over 9 plus 25 over 3. All right, so that's what this comes out to be. And then if you add and subtract all of these terms, you're going to get 41 over 9. So that will be the total distance traveled in meters. All right, I hope this makes sense. Take care. I'll see you all next time.